Okay, we're back, and we are going to write an EPA proposal for the P3 People Prosperity Planet, and yeah, let's just get going here. File, save as, browse, my documents, and let's put this under grants. 2014. And I think it's going to be due sometime October. EPA P3. Open, and we'll call it the narrative, and it's writing this on 14/07/07. And the reason I name these things like so is so that they stay in chronological order. So 14 is the is it the most significant bit or the least significant bit? Might be the most significant bit, and then this last 7 is the least significant bit. It's the last one, but either way, it's going to stay in chronological order with the newest file at the bottom. If you don't put the largest time unit on the left, it won't be in chronological order, and the smallest time unit on the right. So anyway, 14/07/07. We'll call it narrative. We'll put it in here. We'll save it. Okay. So Missoula College Energy Technology Program EPA P3 proposal. Now, I'm just going to start putting some notes in here. So Nash, ref, Lovins, ref, and let's just pop it in. I love using EndNote. EndNote. Go to EndNote. I'll see if I've got, so here's my library. We'll see if I've got Nash in it. Nothing. Alright, so let's go to the web, and let's just go Web of Science, and then we'll do Nash 1950. Right, search. 1 to 27. Whoa, it's too many. Oh, I think I just saw it. Bargaining problem. That's okay, there's 27 there. Okay, the bargaining problem. 155 to 62. Take that. Copy reference to. We can do a new. Just do a new library. And what the heck? Let's just put it in grants. Let's put it in 2014 EPA P3, and we'll call it EPA P3 2014. Save. Okay, there it is. Now we can also, it's fine. Let's just keep it here. All right, now if I go back into my document, I'm going to go Alt-2. It puts it right there. So here's our references. And here's the Lovins ref. Let's see if we can find him. W. And we'll go back into all references. Let's try Lovins. Lovins! Reinventing fire. Bold new initiative. Bold solutions. Okay, I'm going to go and put that bad boy in there too. Okay, so normally you wouldn't have to do all this right up front, but I just wanted to show off my EndNote. My vast EndNote skills. All right, here's Control E to put us in the middle. All right. Now, what do we want to say about the bargaining problem? Problem is 1 in which each person or bargaining partner, this could be nation, company, etc., has a certain number of assets, each of which has a relative and here's where we got it in. Relative, I want to say a happiness value, relative value. I'm just going to type not necessarily based on dollars per se, but more on a general happiness scale. The object excuse me, of solving the problem is to maximize each person's happiness without overly compromising the others. Happiness. When both people, parties, you can say both / all parties are equally happy / equally unhappy, the game, a bargain is struck, and the game ends. How about that? Okay. And now, in our scenario, we are putting a value on each of the three players in the P3 problem, and trying to maximize each. Let's just, so P1 equals people, P2 equals prosperity, and P3 equals planet. So obviously, we do not wish to compromise the happiness of any of these. However, if we, I'm just going to think here for a little bit. However, if we continue on a business as usual approach, we will continue to become increasingly reliant upon the very resources that we are plundering. For example, if we continue to pump CO2 into the atmosphere at our current rate, temperatures, extremes in many parts of the world will continue to climb let's say high temperature. Thus leading to a greater reliance on let's just say coal-fired power plants to make for air conditioner. How about that? So I'm trying to give an example here. Put some subscripts on here. Put some non-breaking spaces in. Okay. Non-breaking space is Control-Shift space. Okay. Now, if on the other hand we are to embrace many of the existing technologies, such as photovoltaics, energy efficient buildings, what I spell photovoltaics, energy efficient buildings, and renewable energy sources, we are likely to encounter a future that not only begins to decelerate climate change, but which also is far less dependent on fossil fuels. Lovins. Think. All right. So there, I managed to get Lovins and Nash in there a little bit. Okay. So let's go back to our notes the other day. Let's save this bad boy. Let's go back to our notes. Give me one quick sec. And what we'll do is, review what it is we're aiming to do with this grant. We'll review the ideas we came up with. I'll leave it a little bit in kind of a brainstorming format, but I figure in this In this scenario, more is more. More is more. Minimize that. Minimize Nash. Did I put Nash into the course? Yeah, there he is. There he is. Nash paper. We covered Love's chapter 1 and 2. That's already up there. Oh wait, hang on. Game theory paper. There it is. There, I'll just kill that one. And then I've also got notes from Lovins here, chapter 4 notes. And that's just we'll look at that a little later. If you want to look at it now, you can, but we're not going to come across that until later in the course. There's the chapter 4 notes. I'll just put in parens, looking ahead. So we won't get to chapter 4 till a little bit later. So we've just done Lovin's chapter 1 and 2. I just showed you a little bit. Lovin speaking at Duke. Let me see. I've got this energy conversion spreadsheet. Let's take a look at that bad boy really quick too. It might help you out. 0 discussions. Please rescue. Please rescue the prof and share your file, Paul. Oh, I remember what that was. You know what I should do? I'm going to do a Control F right now. I bet I have one somewhere. Energy. Oh, this is going to be fun. But we're going to do a. Let's just do the XL. Oh boy. I think I would have named it energy conversion. 5. Let's just take a look at this guy. Ah, there we go. Yeah, let's do that. File. Save as. Oh, I guess it was already in the cancel. Okay, so here's a little energy converter if you want to do this. I got joules, megajoules. So fill this column is what I've got. So if I type in 10 joules, you can see that my converter, let's do 100. My converter ends up converting megajoules, exajoules, barrels of oil, etc. Now, I'm just going to leave this for you guys to play around with a little bit, but basically what you do is fill this column here. I'll put that as yellow, and then the rest kind of fill themselves in. So I put in 1 therm. Let's see, so I put in 10 therms. Okay, nice. That turns into 1 decatherm. All right, file, save, and I'm just going to take this whole bad boy and drag it. So let's dip in there. Energy conversion. Add a new discussion topic, and I'll just say MS Excel energy converter to play with. $250 students. Please use this spreadsheet as a way to hone your energy conversion skills. Now, Has this already been done? Yes, it has been. Is it worth doing again? Yes, it is. So I'm going to go ahead and grab courses, Energy Y 250, and, oops, not 290, 250, 2014, energy conversion. Okay, you can see I'm messing with that. I'm going to just drag it over there, and maybe we'll just play around with it one more little bit here. Documents, courses, 250, 12, energy conversion. Now, when I say has this already been done, of course, it's in thousands of textbooks. But let's just do one on our own. So let's just go from joules to therms, for example. Let's just pop into this guy. So joules to therms. All right. So a joule is, gosh, it's tiny. Let's remember a therm is. I think it's 100,000 BTUs. BTUs to therms. Not quite. Interesting. 1 BTU. Huh. Yeah, so it is. A BTU is a 10,000th of a therm, but not exactly. Why is it not exactly? Let's look at it. I don't know why it's not 10,000. Why wouldn't it be? Must be something else. Natural gas is usually measured by volume in the U.S. and is stated in cubic foot. Cubic foot measurement. Centum cubic feet is to know 100 cubic feet, and MCF 1,000 cubic feet. To provide greater accuracy in comparing fuels, energy content is measured in therms, BTUs. All right. Well, we're just going to go with 100,000. So 1 therm is 100,000. So right here, I've got joules. I've already got. So if I put a 1 in here, I can see that 1 is that many BTUs. Let's just go the other way. If I go BTU, I can see that if I've got 1 BTU, I'm gonna have 2110 joules. Let's make sure that's correct, because BTUs is kind of the middleman here. BTUs to joules. Yeah, that didn't seem right. It's 1,055. So 1 BTU equals that times 1055. All right, so now we've got BTUs to joules is correct. Let's see what that says. Okay, so that's correct. So we got 1 over 1055. And now this is just going to equal BTUs divided by 1 E5. Sheesh. Okay, so 1 joule, 9.47 times 10 to the minus 9th therms. Let's just check this online. Joule. .48. Okay, we'll go with that. Close enough. What if we increase the accuracy of the BTU a little bit here? See if we can nail it. BTUs to joules. So we're looking at 1055, 05585. Okay, so therm now popped up to 947. Let's do BTUs. Let's do therms. Therms to BTUs. Okay, so 99976. 99976.129. 948,034. Sorry guys, this is unfortunately what science and engineering come down to sometimes. Now let's go joules. Joules. 948,043. Perfect. Perfect enough. All right, and then decatherms, basically this guy equals that number divided by 10. Okay, so there's an example. You can play around with it. File, save, file, close. Something to mess around with inside this spreadsheet. Okay, please use the spreadsheet to hone your energy conversion skills. So, showed you how to do a few. You can play with it on your own, and that way, when you're, instead of going to the Google here and just doing like the one at a time stuff that I was, you can look at all of them. Is my attachment there? There it is, right there. Okay, so back into the course. And we don't have a ton of time here, but let's just look at what we had for our energy finance, or I'm sorry, EPA ideas. Lecture 1. I think I just called it Lecture 1. Freakonomics, research models, brain surgery, brainstorming. Kind of felt like it. So let's take our idea matrix. I called L2, and what we end up with? I think we ended up here. We ended up here. And I think we got to thank Paul a lot for leading the way on there. The bring inside PV, dedicated low voltage, and then I'm going to put this as sort of a second option because the emergency power trailer is going to be it's going to be part of it. It's going to be an integrated part of the design. Okay, so let's throw that. Narrative. All right, we see the energy future in a post-fossil fuel world to be one in which a diverse set of energy sources technologies come into play. And I'm gonna say that I'm gonna say something. Since the revolution seems to be slow paced, and one that is hampered economics, we chose a project that is not only appealing. This is not that great, to a large market, but which also can be implemented now with relatively low costs, trouble, what do I want to say, to the consumer. We propose to modify the existing solar yard lights, be integrated dedicated 12-volt DC microgrid systems. We will purchase cells, 3D print a prototype, integrate the lawn cells with a larger dedicated microgrid 12-volt system. This will be demonstrated with our own mobile trailer. Etc. Okay, that's about all I got time for, but so I wanted to get some Lovins in there, I want to get some Nash in there, I want to show our system, and I think what we can do is let's also put local plastics waste to make housing for these units. What else do we do the thing where the light gets pulled in? So I think what we kind of decided we would repurpose these lawn units so that they're on a circuit. Now we've got to do some research. Research existing units, systems. What else do we want to do? Unit system. Standards, too. Etc. Okay, we're looking at that. Because we don't want to, we can't copy something, well, we can't reinvent something that's already been copyrighted. So let's see if somebody's got something similar. Let's come up with some schematics. I'd like to just kind of show where It's kind of a do-it-yourself solar. You've just got this little gardening package where, okay, it's not a big beefy system, but it's a start. It's like an entry level. Entry level. One thing, existing phone lines. Maybe you just take your existing phone line, that becomes your dedicated 6 volt. Or sorry, 12 volt. Be a good one. Do a little metering to see what the line losses are on a built-in home phone line. Could be fun. Could be cool. It's already there. Entry-level existing phone lines. Okay, I'll have to check that out. It's gonna be a good project. Okay, so I'm gonna stop the Camtasia and see you guys Wednesday.